Hello everyone, welcome to Structurepedia. So today we're gonna talk about carbon emissions. Uh, as you can see in the thumbnail, that we are totally focusing on carbon emissions that we see in any building. That is when we construct those buildings or during their operation, during when we end those buildings. So we will study all those details in a very detailed form, and we will try to find out how to calculate those emissions. First first point is that why we need to calculate that, why we need to calculate carbon emissions, what is need for them. As you might be aware of the things that has been promised for 2050, that we have to reduce carbon emission to a certain extent. And for that, as a structural engineer, is it is our big responsibility for us to incorporate those things in our design. And when we design a building, when we uh, construct a building, we try to reduce materials. So less materials means less carbon emission, but without compromising on strength, safety, and robustness of a building. So let's start with the basic concept first, and then as we will move forward with those video series, then you can actually calculate carbon emission for of any building very easily. So first thing is, we need to find out what is a process through which a building does carbon emission. First, there are some codal provisions, that is BSEN 15978, which has the life cycle stages. And so there are total four stages. One is A stage, B stage, C stage, and D stage. So what you mean by these four stages? So our main focus should be on A, B, and C, and I will come to D later on. So with A stage consider A stage has five part: A1, A2, A3, A4, and A5. A1, A2, A3 is the product stage, and A4, A5 is the construction process. Now, if we divide the what do you mean by the product? What is actual product? So the raw material you get, that is cement, aggregates, for example, the reinforcement, the steel reinforcement, and what are the raw materials that you find on a construction. For a construction, you need that all combine and form structural material library, that is structural material supply. And when we prepare our structural materials, before we take it to site, there is some transportation between them. So that is the transportation here we are talking about, which is within the manufacturing unit. So transportation is the transportation that take place during the manufacturing process, and this is the manufacturing. This is we prepare those materials into a structural form that can be used easily on site. So A1, A2, A3 are clear. Now, this is what you have done in a factory or in an on a warehouse, and then we take these materials out of the gate means out of the manufacturing unit, and then we transfer those to the construction site. On the construction site, there is transportation, because if we make a raw material in a structural form, we need to take them to the construction site. It might be on the first floor, second floor. It could be a big site where you have to transport those units. So this could be transportation again, but this transportation is very much different, as I shared before. Other thing is that the construction installation process. So you got a precast unit, you got a steel members, and then you just transport that to the respective floor or respective site location. That is A4. So A4, A5 is the construction process. Whatever construction you're gonna do would lie under A4 and A5. The material preparation, manufacturing will A1, A2, A3. So this is basic layout of A series. After you do the construction, your building is created, your job is done. But the building job is not done in terms of emitting carbon emission. So there are these B series when building is in use. So that is use, maintenance, repair, replacement, refurbishment. So when we use building, so it will do the carbon emissions, and then there would be some maintenance going on in the building. There might be some cracks in future after 10 years, 20 years, so you might need to repair that. You might need to replace some of the beams or columns if the building suffers any disaster or still due to some natural hazards, or there's something that you need to refurbish. So those all comes under B1, B2, B3, B4, B5. This is during usage. Whatever things you see here, this is during usage. Along with that, we have B6 and B7. This is operational energy use and operational water use. Whatever water you're using, whatever energy we are using, due to that as well, we have some carbon emissions. So this is B6, B7. So B unit is totally the usage part. So the building has been used. Now we have to end it. End of life. We have constructed the building, we have used it, now we have to deconstruct it, because if we don't need it, we need to deconstruct it. Once deconstruction is done, you need to transport it. The waste you get from the deconstruction, you need to process that into a smaller form or into a reusable form, and then you can dispose of what you don't need among the entire waste materials. So C1, C2, C3, C4. This is if you see the stages here, you can see the gate, and this is the site, and this is a practical completion. You have completed the building, then this is the end of life, this is usage, and the building has ended. Now this is grave, then you just dispose of means you just send them now damn material into grave. The other thing is that after that is D stage. This is beyond the life cycle, that what is there after you end the life. Here we have what are the benefits, like reuse, recycle. There are some materials, the steel is there, you can recycle it, you can turn them into a different form and you can reuse it. So those other things comes under D stage. Now we need to talk about the percentage. Now, so what is a maximum percentage? A1, A2, A3 is the maximum percentage, that is 50%. After that, B6, operational energy use, the heating system that we use in a building or air conditioning system, whatever you use, that's 23%. B1 to B5, usage, maintenance, repair, replacement, refurbishment, that is 20%. After that is a transport during the construction process, that is 4%. Construction installation process is very less, is 1%, A5. And end of life, which is only 2%. So so through this you can understand that which is more important, where we have to work on. So you can see the raw material. If we can reduce the raw material by like 10%, 20%, then they also will have very big impact on the entire carbon emission of that particular building. So this is details, and I will go further into each of the element later on the later video. We'll meet tomorrow on that. So this is the smaller version of I've sorted out these things, and I will upload that on the website, so you can go through and you can even download this page. Thank you very much. Please like and subscribe the video if you like the content that I'm sharing, and that is where that you find